Hello students, let's continue our notes for 3-6. We have example 4 here, and it's the graphic shows regional air travel data recorded by a domestic airline company. How can you use the data to estimate the number of air miles people flew in 2003? If the trend in air travel continues, what is a reasonable estimate for the number of miles that people will fly in 2030? So let's look at these years, and we're going to say that year 1975 is year 0. And then 5 years later, we have 1980, and 5 years after that, we have 1985. So I'm adding 5 years each time, and that's what we're going to put into our calculators. And then from 2015 to 2030, that would be 15 more years. So 40 plus 15 is 55. And then for 2003, that would be in here. So that would be between 25 and 30. 2000 is 25, 2001 is 26, 2002 is 27, and 2003 is 28. Let's also make note that the 28 that we just figured out was for the year 2003. So this is what we're looking for, and we're looking for this year in 2030. And you're not going to put these numbers into your calculator yet. The only numbers I want you to put into your calculator are 0 through 40, these numbers here. And I want you to put that into our x values for the years. And so that'll go into list 1. So go to your stats on your calculator, type that into list 1, all of these numbers for your x values. And for your y values, those are going to go into list 2, and that will be all of these numbers. And that's the air miles traveled. Okay, so it looks like air travel is increasing. That's what I would say. One of the things that your homework is going to ask is what interpolation and extrapolation are. Interpolation is numbers within your data set. So you can see that 2003, or the 28th year, is within our data set. But the 2030, we're making a prediction 15 years in the future from our data set. So that is making a prediction outside our data set. And I'm going to pause the video right now. After I give these directions for you in your calculator, you're going to go to Stat, and you're going to Edit. You'll need to clear the lists, and you're going to put in L1 and L2 from the airplane graphic. After you put in those values into your lists, you're going to do Stat again, but you're going to choose Calculate, and you're going to choose the 4th option, which is the linear regression. And from there, we're going to get an equation. So I'll pause the calculator for you, or the video for you to put that in your calculator. Once I do that and I calculate my linear regression, I get A is 47.87, and then I'll put my X, and my B is 1,345.04, but I'm just going to round it. So Y equals this. Did everybody get that in their calculator? Okay. Now, we want to make some predictions. We want to make predictions for the 28th year and the 55th year. So to do that, we have to solve this equation by plugging in 28 and then 55 for x. So we'll do that calculation twice. And you can do this in your calculator by going to the calculate screen, so just clearing everything out. And you will multiply by 28 for the 28th year, and then we'll add 1345. So I'm doing that in my calculator right now. And I multiply and then I add. So that is going to equal 2685. So 2,685 miles. And we'll just round it to the nearest whole. So that would be in the 28th year. This is how many miles. So I should write that unit, miles, in thousands. And then we're going to do the same thing. We're going to take the equation, the linear regression equation. We're going to plug in 55. Now this is extrapolation because it's outside of our data set. So I'm going to put that into my calculator right now. 4787 times 55, enter, plus 1,345. See if you get the same thing in your calculator. 3,977.85. So I'm just going to round it up to 8 miles in thousands. So I plugged in 55 and I got 3,978 miles. So this one was within our data, so it's in interpolation, and the 55 was outside of our data set, so he was way out here in 2030. So that would be extrapolation. And when you're ready, turn the page. We're going to skip this try it, but if it was 2012, you could figure out where that would be in your data set, but we're just going to skip it in the interest of time. Example 5. A student found a positive correlation between the number of hours of sleep his classmates got before a test and their scores on the test. Can he conclude that he will do well on the test if he goes to bed early? Does yours have a typo? Goes to bed early. Well, maybe going to bed early might help him on the test, but staying up late and studying might also help him on the test. So it's going to be no, there is no causation he could stay up late studying. And do well on the test. A lifeguard notices that as the outside temperature rises, the number of people coming to the beach increases. Kind of makes sense, right? If it gets warmer, more people will go to the beach. Can she conclude that the change in temperature results in more people going to the beach? Well, not necessarily, because let's say that it's the 4th of July and it's really foggy outside. Maybe people will go to the beach on the 4th of July, even though it's foggy and cold. So no, causation because people may go to the beach on a holiday, even if it's cold. That's just one counterexample. But there's many reasons why people may or may not go to the beach, not just because of temperature. So you're going to do that, try it on your own, and then we're going to work on our 3-6 assignment, and we'll be here to help you, and you can use the calculators on your assignment.